In the previous lecture, we discussed data types, but except for strings, a group of ordered characters, we just show single values, also known as a scalar. A scalar data structure holds only a single atomic value and is the most basic data type. You can see in the image two ways of creating a scalar variable. In this case, a new variable named A is created that contains the value 2. However, using scalars, we can construct more complex data types. For instance, we can generate vectors by concatenating values of the same type. And again, we will need to learn the syntax. In this example, we observe that we are generating a new variable named vec, which is a concatenation of 3 values, 1, 2, and 3. The word C here stands for combine or concatenate, and is in reality, this letter C is a function. As we will see in the coding lecture, we can generate many different vectors of different lengths, etc. But vectors, as I was saying before, must have every one of the items of the vectors within the vectors to be of the same type. If we want to have different types, then we will be using what we call lists. And again, we will need to learn the syntax as shown here. We create a list named LST with 2 elements, each one a different characters. By the way, why do I know they are characters and not variables? Because we observe the syntax and the values are provided between quotations, and those quotations refers to characters. Keep that in mind. We will go again in the video coding lecture. But now we have atomic elements that store one value and vector of list that which contain several. But most of you may have worked with spreadsheets such as those provided by Microsoft, OpenOffice, and in those applications, data is stored in tables, similarly to paper accounting worksheets. In R, we can generate those using the function matrix. And again, we will need to learn the syntax. But before learning the syntax, let us think about it. When we want to create a matrix, what do we need to provide? We need to provide the name of the matrix, we need to provide the number of rows, we need to provide the number of columns, and what are the values that will go inside the matrix. So, see the syntax here. This is more or less what we will be doing, right? Name, and then a matrix is the function that will generate the values, number of rows, number of columns. If you want to know more about this syntax, write it in the console, question mark and matrix, and you will have much more information. Following this syntax, let's see an example here, where we create a matrix with 2 rows and 2 columns, and fill with the value 0. This is very useful, and while matrices are very useful, similar to vectors, they require all values stores to be of the same type. In order to have structures that allows for different data types, also similar to what happens in the spreadsheets, we will need a different data type. In R, we can use what we call data frames. You can think of data frames as a collection of columns, where every column can be a vector of different types. 2 things. To have all the information about generating data frames, as always, you can use question mark data frame, and you will get a lot of information. Secondly, you can guess the syntax. You need to provide the information for each column and the name of the variable. See our example here, where we generated a data frame with 2 columns, where the first one is numeric and the second one contains characters. Why do I know they are characters? because of the quotation marks. One last thing to consider before we start our coding lectures is factors. Factors are list of predefined set of values. Imagine we allow only a predefined palette of colors when we paint. See an example here, which is very easy to understand. In this case, we generated a factor derived from a vector. The vector contains 3 values, 1, 2, and 1. The factor will contain those 3 values, but will associate the values to 2 levels. That's the important thing, that now f is a factor that contains 2 levels. So, finally, remember that you can use a function class to investigate the data types. See some examples here. So now, after this introduction, it is time to go back to coding and the coding lecture.